All right, in this video, I'm going to show you some of the geometry behind this ambiguous case and the law of sines. And the case we're talking about is when you're given two sides and a non-included angle, and we have to test for possible triangles if the opposite side is smaller than the adjacent to see if there is 0 possible triangles that can be formed, 1 possible triangle, or even 2. And I have this activity that we have on paper to follow, and I'm going to be scrolling back and forth because it's kind of laid out in terms of steps. So let's say I have a fixed point called A, and I have A over here on the left-hand side. And so the first thing that we're going to do is from the endpoint of A, we're going to draw a 4.5 inch line that forms a 50-degree angle with the dashed line. We're going to make the endpoint B. All right, so we'll do step 1. And I'm going to use my protractor and eventually use a compass to do this. So I need a 50-degree angle from A. So I need to make an endpoint here. So I'll put a dot right here. All right, so I'm going to make a 50-degree angle off of A. All right, and I need for that to be, it says make it 4.5 inches long. All right, so along there, I need to go 4.5 inches. So 4.5 inches puts me right there, and I'm going to connect those dots. And so that's going to give me my line here. So we have this fixed angle of 50 degrees. Let me double check that one more time. All right, so fixed angle, spot on. This is 50 degrees. So this is my known angle. And we're told that this is 4.5 inches, so 4.5. And we're making that endpoint up here, B. All right, so the endpoint of that line is angle B. All right, so I have a fixed angle, 50 degrees, and a fixed side of 4.5 inches. Now, what we're going to do next is we're going to use our compass to draw an arc that has a radius larger than 4.5 inches. So this is going to be the case of the opposite side being larger than the adjacent side to the known angle. So this would be right here, step 2. So using my compass, 5-inch radius. And I want to know how many triangles can be made. Now the triangles would be formed with the intersection with this dashed line at the bottom. So it'll give me a second. And we'll try to set up. So 4.5 inches. And I'm going to draw an arc. So 4.5 inches. So my 10-inch diameter line on this is right here. Oh, I had to get back to my pen. All right, so my radius line here, I'd have there. It's drawing. Drawing this arc. All right, I'm going to have to kind of split this up a little bit. So I have the arc here, and then it would continue to swing down. And then I keep pulling that arc over here, and I got it right there in red. So and then the intersection here at this point, all right, would be the location of the possible triangle. Which the possible triangle in this case would be if I took and I drew a line from B and connected it to this point. That would be my one possible triangle that I'm viewing right there. So if the opposite side is larger than the adjacent, there's only one possible triangle that can be formed, because the other possibility would be way over here, which I couldn't even make because my acute angle is open towards what would be the outside of that triangle. So only one possible triangle can be formed if that's the case. Now, so this is if the opposite side is larger. So that was if I had a 5-inch side here. Now, let's look at a different case. So this next step here is we want to look and try to determine with the compass, and I want to make a tangent arc and draw a line up to B. Now, a tangent arc means that if I was able to draw this arc, it would just barely skim that dashed line. So it would just barely skim it right there up under it. All right, so let's see if I can get that to operate here. All right, so I want to find the arc. That would just barely skim it. And it looks like it'd be that arc right there. So my tangent part of the arc. And we want to mark that point of where it would be and try to determine the angle that could be formed there at that point of tangency. All right, so I'm trying to determine, looks like my point of tangency is about right there, roughly where it touches. And so if I draw that line back up here to B, to the point of tangency, I want to know, well, what kind of angle could be formed right there? And if I go measure, it should be very close to 90 degrees. And in fact, it's almost perfect right there at 90 degrees. That's a 90-degree angle. Now, what that is, now that's an altitude for a triangle, which is perpendicular to a side and goes up to an apex. This represents the minimum length required to form a triangle, to close in this shape. So to form a triangle. And I'm going to refer to this as H. And so I'm going to turn around, we're going to measure how long that side is. And so let's see here. All right, if I'm going to measure, it looks to be about 3 3/8. So 3 3/8 would be approximately, so about 3.75. And so that would form a 90 degrees right there. Now, if I tried to make an arc with a line that was shorter than H. So we got H to be about, let's say, 3.75. And so if I tried to make an arc with something that was shorter than that, and so I'll do this one here, step 4 in green. So if the side that was given to me was actually less than the minimum length, and I tried to swing an arc down here, what would happen is it would never touch. And so since that arc would never touch, that means I could not form a triangle if the side that was given, or if the arc was given that was too short. So if the line was shorter than H, I can't form a triangle. Because it won't touch the dashed line. Which represents the third side of the triangle to close in the shape. And so now I want to look and say, all right, what happens here if I pick a side. Actually, hold up. I said 3 3/8, didn't I? But it's not 3.75. It's 3.375. 3.375. So I gotta make that correction there. And so let's say I picked an arc length to use to see if I could, what would happen if I formed a triangle that was bigger than my h, so bigger than 3.375, but smaller than 4.5, because if I was bigger than 4.5, we couldn't form a triangle. So let me pick a different color here. Let's go with orange. All right, so step 5, let's see what happens if I pick a number that's bigger than 4.5, but smaller, or excuse me, bigger than my h, but smaller than 4.5. And so I predetermine, say, all right, let's use it, my radius of this arc to be 3 3/4. So that'd be the 7.5 inch diameter line if you got a safety compass like I do. All right, so 7.5 inch diameter line. Where's that? That is right here. So if I made the arc, it's doing the straight line again. So if I made that arc with that side, it actually intersects our unknown side twice. So it says label one that is C and C prime. All right, so we'll make the one on the right be side C. And the intersection over here on the left-hand side, I'm going to call that C prime. And so the number of possible triangles we have, where we have 2 locations for corner apex C in this triangle. We have 2 possible triangles. And so I want to know, what would the measures be for C and C prime? Well, so one possible triangle here is going to be the triangle that is formed. Let me get a different color. All right, so we'll go pink. Would be if I had the fixed side of A, and then I had the side that connected B to this first location of C. So I had from there, and then I went along this dashed line here. And then we had our fixed side. So this whole pink side here. So I'm talking about that triangle as one possible, where C is an acute angle. And let's measure what that angle would be. And so if I'm looking here, I'm trying to measure this angle. It appears to be about 65 degrees. So measure angle C is about 65 degrees. And then I want to say, all right, well, what if the other case was if the triangle had that vertex of C where I have C prime? And so let me see if I got a color I haven't used. Let's go with this color here. So if my vertex was here at C prime, which means that instead I went from angle B at the top, and my this vertex of C was located to the left side of my altitude, and had the intersection there, forming this obtuse triangle here that I have with this green color, where I had that triangle right there on the left, where that obtuse one. Now, if I had that, I need to measure what would that angle measure be. Well, that angle measure would be, so let me get lined up. And I'm looking, and it lines up at exactly 115 degrees. So 115 degrees. Now, what is the sum of C and C prime? Well, if I add up 65 and 115, they add up to be 180 degrees. And so geometrically, all right, just using a compass and a protractor, these are our possible triangles based on given scenarios. So if I have the opposite side larger than the greater, or than the adjacent side, so that was over here in red, we had one possible triangle. So opposite side greater than the adjacent side, we had one possible triangle, which was the big overall red one. So I'll try to stay outside of everything here, so that way we still have this colors to refer back to. Would be this outside one here. And we had the two, if we had the pulled an arc down that was tangent, we had one possible triangle, or we also had one possible triangle, and it was a right triangle. If we were too small, so which is the green one, so the green part here was the opposite side was less than the minimum length required, we had 0 possible triangles that could be formed. And if we had the opposite side that was bigger than H, but less than the adjacent side, so we had here, or I had pink here. So opposite side is less than adjacent. However, but is the opposite side is at the same time bigger than the minimum length. We had 2 possible triangles. We had the pink one, or we had this green one that I made. All right, and this is the ambiguous case. And I have this summarized here in this table right here, which basically takes everything that just happened and it puts it right here into one table, which says that we're always comparing, for this ambiguous case, the opposite side to the adjacent side and figuring out if we have to test. All right, so first case that we have for side-side angle was the red one that I drew, where the opposite side was greater than the adjacent, which means we have one possible triangle. I don't have to do anything. I solve it as is. Now, if the opposite side is smaller than the adjacent, we have to test for triangles. And so we have 3 things that could happen at that point. The first thing that could happen is if the opposite side was less than H, which is the minimum length, which means we have 0 triangles can be formed. Now remember that H in this, H is the minimum length required. To form a triangle. If H equals 1, or excuse me, not if H equals 1, if the opposite side equals H, one possible triangle, and I did that right up here, that's that purple arc that formed a 90. So if the opposite side equaled H, one possible triangle, and it forms a 90. You don't really see that one too often, but that would be what would happen. And then if the opposite side is smaller than the adjacent but bigger than H, we have 2 possible triangles. So the opposite side is bigger than H, so the minimum length, the opposite side is bigger than, but it's smaller than the adjacent. we have two possible triangles, and the angle that is the ambiguous angle in this case would be the one that is on the bottom right. And so that is the ambiguous case. And see in